Hello class, in the last class we learned about the welding process, the form of welded joints, and the common defects in welds. After understanding the target of ultrasonic inspection, the weldment, we will learn the ultrasonic inspection method and technology of weld seam. The content includes the pre-treatment and preparation of the weld, adjustment of the weld inspection instrument, the determination of the scanning method, and the evaluation of the defects. In the welding seam inspection, due to the influence of the weld steam heat and the defects existing in the weld seam, are often close to the vertical or form a certain angle with the inspection surface. So in general, the ultrasonic wave is obliquely incident inside the workpiece, namely the shear wave inspection method. And then we can take the inspection of medium and heavy plate butt welds as an example to illustrate the matters needing attention in the process of ultrasonic inspection of welds. 1. Pre-treatment and preparation for welding. Before the ultrasonic inspection of welds, the workpiece to be inspected must first be pre-treated and prepared accordingly. For welded parts, it is necessary to ensure the flatness of the dictated surface so that the probe can be well coupled on the surface for inspection. Generally, the mechanical cleaning method is used to deal with the spatter, oxide scale, etc. And the roughness of surface is generally not greater than 6.3 mul. The trimming values of the inspection surface needs to consider the standard calculation method, taking MBT 47013.32015, non-destructive testing pressure equipment part 3. Ultrasonic testing as an example. When using the primary reflection method inspection, the moving area of the probe should be greater than 1.25 p, and the inspection area of the probe should be greater than 0.75 p when the direct beam method is used for inspection. Here, p represents the span. P is equal to 2 times the K value and then times the plate thickness T. The frequency should be selected according to the material and thickness of the workpiece to be inspected. In general, the frequency, the higher sensitivity, and it is easier to determine the location and the size of the defect. However, the higher the frequency, the greater the attenuation of the sound wave, and the thinner the thickness of the plate that can be detected. Generally speaking, the smaller the thickness of the steel plate, the higher frequency is used. When the thickness of the plate is thick, or the attenuation of the sound wave by the material is obvious, the low frequency should be selected. In weld inspection, the inspection frequency of thin plate is mostly 2.5 to 5 MHz. The inspection frequency of medium and heavy plates is mostly 2 to 2.5 MHz. The K value of the probe should be considered from 3 aspects. Firstly, the sound beam can scan the entire weld section, and the K value is greater than or equal to half of the width of the upper weld plus half of the width of the lower weld plus the front edge distance of the probe divided by the thickness of the specimen. Secondly, the center line of the sound beam should be as perpendicular to the main dangerous defect as possible. Thirdly, ensure sufficient inspection sensitivity. Welds with higher quality requirements require more sound beam incident directions to find defects with different orientations as much as possible. The inspection direction is at least one-sided and one-sided inspection. When the requirements are higher, two-angle single-sided or double-sided single-sided inspection can be used, and tandem scanning can be added. It is also possible to request the residue height to be smoothed, as well as add parallel scan, oblique parallel scan. Select the key value and the inspection surface according to the table on the standard. In different standards, different inspection levels are specified according to qualified requirements, and principles are given for the inspection surface and inspection direction. For example, in NBT 47013.3, the inspection grades are divided into ABC 3 grades according to the weld quality requirements, and the completeness of the inspection and the difficult factors ABC increase step by step. Secondly, the instrument adjustment. Instrument adjustment include time baseline scanning ratio, joint distance amplitude curve, and determining inspection sensitivity. In weld inspection, there are 3 ways to adjust the time baseline, which we have learned in the previous course, namely sound path adjustment, horizontal positioning method adjustment, and depth adjustment method. In recent years, digital ultrasonic flow detectors are widely used in weld inspection. The instrument can automatically give the position parameters of defects, and the sound path adjustment method is often used. During the distance amplitude curve is used for the quantification of defects. The drawing methods of the distance amplitude curve, different standards, are similar. It consists of evaluation line, a quantitative line, and a rejection line. As shown in the picture, there is divided into 1, 2, 3 areas. The adjustment of the welding sting inspection sensitivity is to ensure that the required inspection signal has a sufficiently high amplitude. So the standard stipulates that the inspection sensitivity is not lower than the sensitivity of the evaluation line. When detecting later defects, the sensitivity of each line should be increased by 6 dB. There are 3 specific sensitivity adjustment methods. The first method is to adjust the sensitivity with a comparison test block, and use a test block with the same material and surface state as the test piece for adjustment. Adjust the horizontal hole to the reference wave height and increase it by 16 dB. Then the sensitivity adjustment is completed. The second is to use the panel curve to adjust the sensitivity. Use the comparison test block to check the panel curve first, and then use the decibel difference between the attenuator gain reference line and the evaluation line to complete the sensitivity adjustment. The third method is to use the distance amplitude to adjust the sensitivity. First, use the comparison test block to check the distance amplitude curve, and then, according to the thickness of the base metal, find out the abscissa on the distance amplitude curve corresponding to the thickness of the base metal, or twice the thickness of the base metal. Evaluate the magnitude of the volatility of the line. Adjust the heading of the attenuator knob to the checked amplitude value to complete the sensitivity adjustment. It should be noted that when there is poor coupling between the test piece and the test block, corresponding transmission corrections are required. Thirdly, determination of the scanning method. When scanning the weld, as shown in the picture, 4 basic scanning methods can be used: front and rear, left and right, color, and surround. Special scanning methods such as zigzag, oblique parallel, tandem, V-shaped, and cross are available. Usually, when scanning longitudinal defects, the probe is placed on one side of the weld. The direction of the sound beam is perpendicular to the axis of the weld, and the scanning is performed along the zigzag route. During scanning, the probe should be rotated 10 degrees to 15 degrees. The movement distance of two adjacent probes should be ensure at least a 10% overlap of the probe welds. When the defect is found, the maximum value of the echo can be found by scanning left and right and scanning back and forth. And the indicated length of the defect along the direction of the weld can be determined by scanning left and right. Fourthly, the evaluation of defects. In this inspection of welded joints, when the defect is found, first of all, it should determine whether the defect is located in the weld, and then evaluate the defect amplitude to determine the area where the defect amplitude is located on the distance amplitude curve, and also measure the length of the defect's indication, and then evaluate the quality level of the weld in combination with the stipulations in the standard. In the following part, we use an example to briefly illustrate the evaluation method. The butt weld with a thickness of 30 mm found two defects in the inspection process. The defect F1 is 101 mm. As we can see the formula representing the position of the defect F1 in the weld. And it can be seen that the indicated length of defect F1 is 8 mm. The echo height of the defect F1 is 4 dB higher than the quantitative line, so the defect equivalent is SL plus 4 dB. According to the standard welded joint quality grading table, the indicated length of 8 mm is less than L equal T and 10 mm, as we can see the formula. The area where the reflected wave height is located in the second zone, and the quality grade of the welded joint is grade 1. In addition to butt welds, there are fillet welds, lap welds, pipe seat fillet welds, etc. After class, please try to further your understanding of weld inspection, including ultrasonic testing methods and technologies of these welds. And in practice, try the operation method of ultrasonic welding seam inspection. That's in the end of today's lesson. Goodbye.